What's good, math family? In today's EOC Test Prep video, we're looking at rational exponents. So I'm going to show you guys how to simplify exponents that have decimals or either fractions. So as we start this video out, first thing we want to do is to take this decimal and convert it to a fraction. So I move my decimal place over 2 places to the right, make it a whole number, and now I'm going to divide that number by 100. So I simplify by 10 to get 15 over 10. And when I divide that top and bottom by 5 to get it to its lowest terms, I get 3 over 2. So what they're asking us to simplify is 3 to the 3 over 2 power. Now, before we simplify, we have to remember this exponent radical rule, which is, right, we have a exponent that is a fraction. The top number represents the power, bottom number represents the root. And if we convert this to radical form, right, we know the power is going to be under the radical next to the base, and the root is going to be the index. And if you don't see a number, always assume it's 2. So now that we understand that, what they're asking us to do is to take 3 times 3 times 3, basically take the square root of that, simplify it. And what we understand is every time we have a pair of 3's, right, that's a perfect square, and we could pull it out from under the radical. So this right here, we cancel those two out. They come from under the radical as 3. And this one that's left by itself, it does not have a pair, so it stays under the radical. So we have 3 radical 3 as a final answer, which would be B. But hold on. Another way to think about this is, what is 3 times 3 times 3? 27. So what they're basically asking us, right, is to simplify radical 27. Because like I said, 3 to the third power is just 27. And now if we're trying to find the square root of 27, we would break this down as what? The square root of 9 times 3. That gives us 27. That's the same thing. Then when we simplify, that's a perfect square. It comes out as 3. This, because we can't simplify it, stays under the radical. Now, before we go, if this has been helpful or just a quick reminder, smash the like button for us and comment down below if you guys want some more practice problems. But in most situations, you're going to see something similar like this. And I'm going to do the exponent form and the radical form. So let's say we had 4 to the 1.5 power. Luckily for us, we already know this converts to what? 4 to the 3 over 2 power. So basically what they're saying to us is, we can look at this as 4 times 4 times 4, right? Perfect square, 2. Perfect square, 2 again. Perfect square, 2. So just remember that this is the same thing as 2 to the third power, which is just equal to 8. Now, let's say we kept this in just straight fraction form, right? Sometimes they call it exponential form. I like to say fraction form because this keeps it simple. So when we're back here, let's rewrite this. We could rewrite this as what? 2 squared, because 2 squared is the same thing as 4. And then we take this to the 3 over 2 power. Now remember, we're multiplying a whole number by a fraction, so we could put this over 1, multiply top by top, bottom by bottom. So when I simplify this, what I'm going to get now, let's bring this right here, is 2 to the 6th power, right? 2 to the 6 over 2. Now when we simplify this fraction, this is equal to 2 to the third power, which is equal to 8. And before we go, I'm sorry I keep doing this to you, family. Let's think about it one more way. What is 4 to the third power? 4 times 4 is 16, times 4 is 64. So basically, they're asking us for the square root of 64, which is 8. So this is why it's so important to understand these two rules, because we solve this problem one way right here, another way right here, and then when we look here, we also did this 3 different ways. So like I said, family, if you need more practice problems on this, comment down below, let us know. And thank you guys so much for joining us again on another EOC Test Prep video. Thank you guys so much for joining us today on Algebra 1 with Mr. Peters.